Trends in the alkali metals. As we go down in a column, we observe increasing atomic radius, increasing density, increasing reactivity. Things that are decreasing are ionization energy, electron affinity, and melting point. Alkali metals have very low ionization energy. They form ions quite easily. They're good reducing agents. They're easy to oxidize. They're very reactive. Their compounds are generally soluble in water. This is all just kind of, you could read this and remember it just as much as me reading it to you. Let's look at the reactions that these alkali metals undergo. Alkali metals react vigorously with nonmetals, such as the halogens. So an alkali metal plus a halogen is going to form an ionic compound. Alkali metals react explosively with water. You don't want to put alkali metals in water. They go kaboom, basically. So the metal plus water, what happens is these alkali metals lose electrons. Loss of electrons is oxidation. They're easily oxidized. So they form an ion. And then we get hydroxide ions being formed and hydrogen gas. And it's a very exothermic reaction. And so it's explosive because you've got heat and hydrogen gas. And that's a recipe for an explosion. The halogens have these trends. They have very high electron affinities. They want to get an extra electron. They're good oxidizing agents. That means they're easily reduced. They're also very reactive. So we see that these react with metals to form metal halides. Halogen is the name of the group. Halide is the name of the ions that the halogens form. And they react with hydrogen to form hydrogen halides. And so then we should be able to predict some of the reactions. So write a balanced chemical equation for the reaction between aluminum metal and chlorine gas. Well, let's start out by just writing the reactants. Aluminum metal, well, that's going to be a solid. Chlorine gas. Chlorine is a diatomic element, so it's Cl2, and it's a gas. And then what are these guys going to do? Well, the halogens react in a way to gain an electron. And so these are going to go to chloride ions. And where are they going to get their electrons? They're going to get them from aluminum. So we're going to get aluminum ions, and we're going to get chloride ions. And we look at the charges to figure out what the formula for the compound is. And we're going to get AlCl3. That's an ionic compound. Is that going to be a solid, a liquid, or a gas at room temperature? Ionic compounds have very high melting points. So ionic compounds are going to be solids. This is not occurring in an aqueous solution. This is, you've got aluminum metal and chlorine gas. It's going to react. Chlorine gas will corrode aluminum. And then we have to balance it. Here we've got 3 chlorines and 2 chlorines. So if we put a 2 here, that gives us 6. And then we put a 3 over here and get a 6. So now chlorines are balanced. And then we put a 2 over here. And there's our balanced chemical equation. Questions? I know I'm going through this fast. How about the reaction between lithium metal and liquid water? Well, start with the reactants, lithium metal, liquid water. Well, what does lithium want to do? It wants to become an Li plus ion, right? So that's going to form an Li plus ion. It does that by losing an electron, right? If it loses an electron, somebody else has to gain an electron. All we have over here is water. Water must be gaining an electron somehow. Well, we have sometimes thought of water as being H plus and OH minus. It does ionize to a very small degree. If we have to put an electron on one of these, which one are we going to give it to? Have you ever seen OH2 minus? I haven't. How about H0? That's more likely, huh? So if this is losing an electron, it's probably going to give it to the hydrogen, and so we're going to get rid of that charge. Well, if we have hydrogen, the element, is it just going to float around as hydrogen atoms? Horses need oats for clear brown eyes. Horses, hydrogen, diatomic element. That's going to be H2. So we're going to end up with lithium ion. This one, we have water here, so we could have aqueous things. So we're going to have lithium ion, and we're going to have H2. What's the state of hydrogen at room temperature? It's a gas. And then we're going to have hydroxide ions. And then we have to balance that. The lithiums are fine, the oxygens are fine, the hydrogens not so much. So if we do 2 of those and 2 of these, yes, question? Yeah. So you might think that, well, this is cool. We've got the right numbers of each letter, right? What about the total charges, though? What's the total charge on the left side of the arrow? 0. The charges have to balance as well. On the right side, we've got +1 and -2. We've got a -1 charge on this side. That can't happen. Another way to think of it is one lithium atom gives one electron to a hydrogen, but we've got 2 hydrogens that got electrons. So there must be 2 lithiums involved, and so we actually need a 2 in front of the lithium. Gaseous hydrogen and liquid bromine. So gaseous hydrogen and liquid bromine. What are those guys going to make? Halogens react with hydrogen to form hydrogen halides. Well, they're going to form HBr. And so that's going to be, we need a 2 here. I would not expect you to know the state of this, but I think it's going to be a gas. Questions? You're probably thinking, I didn't get any of that last part. Sorry. Yay.